In this video, we're going to show how to connect Unreal Engine to any third-party API using a simple and practical approach. For this first part, we'll keep things really straightforward, just a basic GET request example so everyone can follow along no matter their experience level. I'll upload all the project files and code to GitHub so you can check the code or copy anything you need directly from there. If there's interest or requests for more advanced topics, like using post methods, extracting data into separate variables, or even handling update and delete requests, I'll expand this project and update the GitHub so everyone always has access to the latest version. To get started, I'm using Unreal Engine 5.6 and creating a new project named UnrealAPICallSample with the blank template and C++ selected. This setup is clean, quick, and perfect for testing API integrations. You can use these steps in any Unreal project, but I'm using a blank C++ template for clarity. I'll set the project name and location, then hit Create. Once Unreal loads, we'll jump right into the code. First, I go up to the Edit menu and open Editor Preferences. Under General, I scroll down to Live Coding and disable Enable Live Coding. This is just my personal preference. It usually gives me a smoother experience, and I find hot reload less reliable with the live coding turned on. You can keep it enabled if you want, but I don't recommend it. For my IDE, I use Rider non-commercial. If you want to set up Rider as your default Unreal Engine IDE, I have a separate video that covers the setup in detail. Next, I go to the Tools menu and select New C++ class. In the wizard, I switch to the All Classes tab, then search for Blueprint Function Library. I select Blueprint Function Library, click Next, and leave the class name as my Blueprint Function Library. This class will let us create static, global blueprint nodes that work anywhere in the project without needing to create child blueprints or set up inheritance. I also have a dedicated video on Blueprint Function Libraries if you want a deeper look. Now I click Create Class and wait for Unreal to generate the new class and open it in my IDE. Once that's done, we'll start adding our static API call function in the header file. At the top of the header, we set up a delegate for handling the API response in Blueprints. This line uses declare dynamic delegate to params, which tells Unreal we want a delegate that can pass two values back. The first part on API response is just the name we're giving this delegate. The next two parts define the types and names of the data it will send, an integer called status code for the HTTP response code, and a string called response for the data returned by the server. This delegate acts as a bridge, so when our API call finishes, we can fire off a blueprint event with both the status code and the result, making async workflows much easier to manage. Now we need to declare our static function in the header file. I'll add it under the public section so that it's accessible from anywhere in the project, including blueprints and other C++ classes. This line uses the ufunction macro with blueprint call able, which means we can call this function directly from blueprints. The category parameter just helps organize our node in the blueprint editor so it'll show up under API and HTTP. The function itself is static, which makes it a global utility function. No need to create an object or instance to use it. Void means it doesn't return anything directly. Instead, we'll handle the response asynchronously. The parameters here are const string reference for the URL, which lets us pass in any web address we want to call, and const on API response reference as the callback, which is a delegate that lets us handle the API response in blueprints once the HTTP request is finished. So to recap, public, so it's accessible. Function with blueprint call able, so it appears in blueprints. Static, so it's global. Void since the data returns later through our event, not as a direct output. URL as the input and callback as the event for handling the result. With this declaration, we're ready to implement the function in our C++ file next. Once the function is declared in the header, I right-click on the function name and let Rider generate the function definition inside the CPP file. Before we start implementing the logic, we need to add a few important include statements at the top of our CPP file. These lines bring in Unreal's HTTP features so our function can actually send web requests. First, we include HTTP module. This gives us access to the main HTTP system in Unreal. Next, we include interfaces HTTP response, which lets us work with the responses we get back from the server. And finally, HTTP brings in some of the core types and classes we'll be using for the request itself. Without these includes, Unreal wouldn't recognize the HTTP related code in our function, so always make sure these are at the top before you start writing your logic. Now let's break down how the function actually works. First, we get a reference to Unreal's HTTP module. This module is what allows Unreal to send and receive web requests. If the module isn't available for any reason, we exit the function right away to keep things safe. Next, we create a new HTTP request object. We set the HTTP verb to get, which is what you use when you want to pull data from an API. The URL is set to whatever string we pass in, so this node is completely flexible for different endpoints. Below that, you'll see a couple of optional header lines. These are commented out for now, but if your API needs authentication or expects data in a certain format like JSON, you can easily add things like an API key or a content type header here. Then we set up the async response logic using a lambda. This part is what actually handles the result when the HTTP request finishes. It checks if the request was successful and if we got a valid response. If everything's good, we grab the status code and the response string. If something went wrong, we use a default error message instead. The last step inside the lambda is using our delegate callback to send the results back to Blueprint. That's where your Blueprint event gets triggered with the status code and the response data. And finally, we call process request to actually send the web request out. With this setup, you now have a Blueprint node that can call any API, handle the response asynchronously, and pass the results back into your Blueprint logic, making your Unreal projects much more dynamic. Before we build the project, there's one critical step we can't skip. We need to add HTTP and JSON to our public dependency module names array in the Build.cs file. You can see the Build.cs file here inside the source folder of our project. Without these dependencies, Unreal won't be able to use the HTTP and JSON features we've set up. In fact, if you forget this step, the whole system will crash and the project might not even load up again until you fix it. So inside the Build.cs file, look for the line that adds modules to public dependency module names. I'll add both HTTP and JSON to the list right after the default modules like core and engine. With those added, I'm ready to build the project and wait for the compile to finish. Once it's done, our Blueprint API node will be fully integrated and ready to use in the editor. Now that the project is built, I'll switch back to the Unreal editor. Instead of using the default map, I open the content drawer, right-click inside it, and choose level to create a brand new empty world. After naming it, I open this new level so we have a clean environment for testing our Blueprint node. Next, I open the level blueprint from the editor menu. Inside the graph, I start with the event begin play node. I right-click on the empty space, and under the API category and HTTP section, I find my fetch data from URL node. For this demo, I'm using the JSON placeholder test URL. This lets us check if our function works without worrying about authentication or special setup. You can use this URL or swap in your own if you want to test a different API. From the callback pin, I drag off and create a custom event. Then I take the response output from that event and connect it straight to a print string node. This way, whenever we get a response from the API, it's printed directly to the screen so we can see exactly what comes back. With everything wired up, I hit play. After a moment, you'll see the API response printed at the top left of the screen. That confirms our Blueprint node is working, and we're getting data back from the API, all without any extra plugins or complicated setup. That's all you need to set up a simple GET request from Blueprint using a static C++ function. If you want more advanced features like post, delete, or parsing and displaying the data in variables, just let me know in the comments. And if this helped you, subscribing really helps support the channel and lets me know you want to see more advanced tutorials like this.